from a social engineering standpoint, I've always suspected that every appliance should come with its own free energy power station, and thus the power station inside that appliance is geared for satisfying the needs of that appliance. If it's a constant load, then everything is straightforward. But in a variable load situation such as a car, the solution, I think, has already been found insofar as when they did experiments with my car that I have in storage, my dead electric car, when Toyota did the experiment, when Alan Coccioni did the experiments on behalf of Toyota, they came up with a hybrid concept because he found that cruising speed on the freeway, when you're just traveling along at the speed limit, doesn't require a whole lot of energy. It's about 50 amps. It's only when you accelerate that you need the extra power. So they made the decision, a management decision, to only use the battery pack during acceleration, and then when you're cruising, you're using the hybrid unit, the little, he had a motorcycle engine running off of gasoline to produce the 50 amps for cruising speed, and thus was born the concept of the hybrid. So I think, once you figure out how to create free energy, then it becomes a management issue. How can you use it? Because sometimes it's the configuration of the device is just not practical, because it's all over the map instead of where you want it to be. But if it's a simple device that merely builds up power over a certain duration, and thus you could say a certain level of efficiency, then it just becomes a question of having to spend it in a certain length of time versus building it up in a certain length of time, and then you just do the math of having several units in rotation in building up power, and then the extra one, you add one more for spending it. But that's the way I think free energy should work from a socialistic or a social engineering standpoint or a management standpoint, because it's not consistent in its output. Generally, this sort of thing has to either build up or be spent. So I think each appliance should have its own power station that's geared for that appliance. Like a blender is a fixed unit, unless there's heavy material in there that you're trying to blend, and that puts a strain on the motor. But a light bulb, for instance, a light bulb doesn't have a variable load. It's always the same level of load, and so you can readily engineer the situation so that the power station for that light bulb always has a consistent amount of power available, one way or another. A good example, I might as well give you an example. Leroy K. Rogers in Iona, Florida. He's been working on a system since at least 1980, but that's when I found out about it, so it's sometime prior to that. And he's still around as far as I know. He's a trucker by day, it's his day job. And he's already got 3 patents to his name. When I first heard about him in 1980, he had only 1 patent to his name. Now he's got 2 more. And he has 4 tanks of compressed air. 3 of them, he spends time building them up, while the 4th one he spends, so he puts them in rotation. So that's where I get that idea for what I suggest to you. Because free energy is a question of building it up, just the way you describe it. You build it up. And so then it just becomes a question of how quickly do you think you can spend it. And then you just have to have multiple units building it up, while the extra one, you add one more to spend it within the certain duration of time. So when Eric Dollard says there are 3 ingredients to the fabrication of electricity, I like to think of capacitive reactance and inductive reactance as being 2 of them. But time, the 3rd one, has various features. You know, he calls it the dielectric and the magnetic, which to me sounds like the capacitive force and the inductive force, but be that as it may. But time has various facets. One is phase relation, another is frequency, and a third is duration. And when you're dealing with reactive power or free energy, duration is an important consideration, because depending on the efficiency of your device will determine how long it takes to build it up to the level that you need it to be at, in order to deliver power at the level that your load requires. So if it's an EV and if it's 100,000 watts, then, well, okay, how long does it take to build it up? How long does it take to spend it? You know, it's just a management issue, more than anything. If you can find a supercap to store the energy, I've used that technique in the past to try to give a certain consistency to its usage against a load. And that's also a good test to find out, in actuality, how much energy are you actually creating, or is it all voltage with no amperage? You know, how much power are you actually creating? Or how much energy, I should say, per unit of time. That's usually a good test. So that becomes your primary load to interface, to act as a buffer or interface. Not a buffer, but it is a buffer, to interface against your load. Actually, as an aside, that's another thing I found that many of my circuits required to help stabilize their output were buffers. And they came in the form of resistors, and sometimes all it was a simple 1 ohm resistor put in the right place. And then another buffer would be a capacitor in parallel with how you deliver your load. That would be in a different place and serve as a kind of steadying force, so that you don't have to deal with this issue of, I got to have 3 units of building up power, and the 4th when I spend it. You don't want to do that. You just want to spend it and build it up at the same time. So then you have to put in buffers to act as go-betweens, so that they are loads you place on purpose inside your circuit in such a manner or in such a position that they don't jeopardize your ability to do what it is that you do. So they're in a neutral position, and being there, they act as a buffer to help even out your production of power, so that you can hook it up to a load and not run into managerial issues of, oh my God, I spend it 3 times faster than I build it up. Hopefully, that's, I hope some of these ideas help. Because interfacing, it does become a challenge, since free energy is not the same as conventional power, and so then it becomes an interface or management issue. Anyway, so you would be, I'm suggesting the application or the insertion of an artificial load that serves no useful purpose other than to strengthen the consistency factor of what otherwise is an inconsistent variation of power level. In the case of resistors, they might be in series, placed in some innocuous little position within the circuit that doesn't affect anything adversely, that if you put in a 1 ohm resistor, it's still okay. It could be a capacitor in parallel near the output or at the output. And it can also be a battery in parallel. There's a fellow by the name of Callanan, Ossie Callanan. There's a PDF file that is floating around the internet in which he uses a variation of John Bedini's switching, little girl switching circuit, and he has a mechanical relay. But in order to make use of those spikes, he says he has to run them across a bank of dead batteries. These are batteries that are not damaged, they're simply dead. And he buried a whole bank of them in an array involving both series and parallel connections in the dirt underneath his home. And then he runs his free energy device through or across the terminals of that array of dead batteries, as he puts it in his words, in order to make the free energy, he calls it radiant, in order to make the radiant energy usable. So here he's got a buffer, but it's a conversion buffer in this case, although I see it as simply a buffer because he's got radiant energy spikes in which he wants to convert into something more similar to what we're accustomed to, which is a nice undulating sine wave in which the power level doesn't rise or fall a whole lot over the course of one cycle of that sine wave. I mean, that's a certain level of consistency that we've become accustomed to, and that was his solution. So, I mean, these are all ideas, but they're management issues. And I guess that's what you're asking, is a management question. I'll try and find, I have a copy of it on my website. I think it won't be hard for me to find it, and I'll send you a link to it. As for Leroy K. Rogers, I don't know if it would do you much good because I just described it, and that's the simplest way to really understand it. He puts things in rotation, which is, one of the things that John Bedini suggests. But usually he suggests it in the course of satisfying a simple battery swapping situation, which is not. It's actually fundamentally it's the same thing. It's a management issue. It's just that sometimes you can't get the build-up as fast as you would like, and then you have to have multiple instances of your storing power versus your spending. It might be the temporary storage that you have to have multiple instances of, or the actual power station itself that you have multiple instances of, whatever it takes in the given situation to satisfy the management criteria. Anyway, just some ideas.